Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video, we discussed the concepts of continuity and we solved the problems of continuity. So student, now in today's video, let us discuss differentiability. Differentiability. So student, this is not a new chapter to you people because in first PUC you studied limits and derivative. This is nothing but differentiation, derivatives of a function. We know if there is a function y is equals to f of x. In our lower classes, that is first PUC, we studied how can we find the derivative of this y with respect to x, because here y is dependent variable and x is independent variable. This x is an independent variable and this y is dependent variable. Dependent variable. So in differentiation, what exactly we'll do? We'll always differentiate the dependent variable with respect to an independent variable, and that is represented as dy by dx. That is, d by dx represents the derivative. D by dx represents the derivative. Derivative of which function? Y function. That is, we'll call it as dy by dx. So in general, d by dx, if we mention, it is called as derivative. And next to that, whatever we write, it is a function. So derivative of this function is differentiability. So now how can we find the derivative of different functions? In our first PUC, we studied a concept called first principle method. With the help of that method, we derive lot of derivatives, and that says that dy by dx is equals to limit h tends to 0 f of x plus h minus f of x whole divided by h. And this is the formula we will use to find the derivative of any function. Here y represents as a function because y is f of x. And student, this kind of functions are called as explicit functions, explicit forms, because here y is purely separated from x, or in other words, we can read this as x is separated from y. Now student, after this, let me write the derivatives of some important functions. Okay students, now let us see the derivatives. Derivatives of different kinds of functions. First, d by dx of k. K is constant here, so its derivative is 0. D by dx of x, its derivative is 1. Then third is d by dx of x power n. Function power constant comes, then constant into function power constant minus 1. That is n into x power n minus 1. So student, with this derivative, we can derive lot of derivatives. For example, what is the derivative of x square? You can write 2 into x power 2 minus 1. What is the derivative of x power 3? 3 into x power 3 minus 1. What is the derivative of x power 9? 9 into x power 9 minus 1. Like that, with this formula, we can derive the powers of x derivatives. It can be minus or plus. So student, with this derivation, with this formula, we can give a conclusion that if we are differentiating a function, then we are reducing its value. We are reducing the function. We can just check here. The power of this x is n before differentiation. After differentiation, the power of x is reduced to one number. So that means the power of x reduces means its degree is decreasing or its order is decreasing. So we'll get less values of x after differentiation. Next is d by dx of root x, 1 divided by 2 root x. Next, d by dx of 1 by x, it is minus 1 by x square. Next, d by dx of e power x is e power x only. Next is d by dx of log x is 1 by x. Next, d by dx of e power ax. If any constant multiplies to x here, then that will become a coefficient of the function, a into e power ax. Ninth, d by dx of a power x. A is any constant here and its power is a function. Then its derivative is a power x into log a. Obviously, students, if I am not writing any base to log, it is understood that it is e. E is the base here. So, student, these are the some basic derivatives of algebraic functions and exponential and logarithmic functions. Now, let us discuss or let us write some derivatives of trigonometric functions. So that is d by dx of sin x, it is cos x. D by dx of cos x, it is minus sin x. D by dx of tan x, it is secant square x. Next is d by dx of secant x is secant x into tan x. And the next is d by dx of cot x is minus cosecant square x. Next is d by dx of cosecant x. It is minus cot x into cosecant x. Students, these are the 6 basic derivatives of trigonometric functions. Very simple it is. The next, let us see the derivatives of inverse trigonometric functions that are very, very important in differentiation chapter. D by dx of sine inverse x is 1 divided by root of 1 minus x square. Next is d by dx of cos inverse x is equals to minus 1 divided by root of 1 minus x square. The next is d by dx of tan inverse x. Its derivative is 1 divided by 1 plus x square. And the next is d by dx of cot inverse x is equals to minus 1 by 1 plus x square. And the next is d by dx of secant inverse x, that is equals to 1 divided by x into root of x square minus 1. Then next is d by dx of cosecant inverse x, that is equals to minus 1 by x into root of x square minus 1. Now student, these are the basic 6 inverse trigonometric derivatives. Now student, here in trigonometric derivatives, if any multiple angle comes, then what are its derivatives? Let us discuss now. 22 number, it is d by dx of, suppose, sine ax. So here I got a multiple angle. This is a direct angle, but here a is multiplied to x, so it is called as multiple angle. So student, whenever this kind of multiple angle comes, whatever the multiple is there, that we will write before the derivative of the function. That becomes a. A is a multiple here. The next, what is the derivative of this sine? Cos. Derivative of sine is cos. What is the angle for this sine? It is ax is the angle. The angle for sine function is ax. So its derivative also have same angle. The derivative of function, whatever the angle exists, so students, from here we should be careful. Whatever the angle exists to the function, same angle will come to its derivative also. So derivative of sine is cos, but angle remains same, ax. Before that, we will multiply the multiple angle to its derivative. Like that, d by dx of cos ax. So student, here again, multiple angle is a. So that I should write first. And I know the derivative of cos is minus sine. So first I will write minus, then sine. Then angle is ax. The next is d by dx of tan ax. A can be any number. A can be positive, A can be negative. A is any real number here. So its derivative is first constant, that is multiple a. Then derivative of tan is secant square. Its angle is ax. So since similarly we can write other derivatives also. For example, if I take the derivative of secant ax, d by dx of secant ax. Here the angle is ax, so its derivative is a into secant ax. Angle remains same for its derivative also, into tan ax. But multiple angle, whatever the coefficient of x is there here, that will write only once. Now suppose if the multiple angle comes like this, instead of trigonometry, if it Okay, exponential already we discussed in the form of e power ax. So students, these are the basic derivatives which are very, very important. If you remember these derivatives, then differentiation is completely very, very easy for you people. Student will feel that differentiation is very difficult. The only thing is because they will not memorize this derivative and the formulas of trigonometric. If you know the formulas of trigonometry and this much derivatives, you can easily solve any kind of problems of differentiation chapter. And since after this, in our first PUC, we studied the two basic concepts of differentiation. The first concept is product rule. Product rule we studied. Of course, before that we studied how addition and subtraction of differentiation. That is very simple. Now we will discuss product rule. This is the very basic rule we studied in our first PUC differentiation chapter. What is product rule says that if there is a function y and it has two functions of in terms of x. Here u and v are the functions in terms of x. In general, product rule is also called as UV rule because we will represent first function as u and second function as v. Then product rule says that its derivative has first function we should keep as it is, then differentiate the second function with respect to x plus addition of this, keep the second function as it is and differentiate the first function. So this is the concepts we will use in product rule. Okay students, the second rule we studied in our first PUC is quotient rule. Quotient rule. This is the second rule of our differentiation chapter. What does this say? That if y is a function and the function is in this particular form, u by v, if the function is u by v form, that is numerator and denominator, then its derivative can be written as v into, it is denominator, into derivative of numerator minus numerator into derivative of denominator divided by square of the denominator, that is v into derivative of u minus u into derivative of v, all divided by square of v. Now students, this is our till first PUC we have this concept and we studied the problem based on product rule and quotient rule as well as addition and subtraction of the functions. Now students, let us start the second PUC chapter, second PUC topics, and in that the first topic, that is the third rule of differentiation, is chain rule. Chain rule. From here our second PUC syllabus starts. But before we go to the second PUC syllabus, we should have the previous year knowledge. Without that, second PUC we find it's very difficult. So that's why I briefly explained the concepts and the derivatives of the first PUC. Okay. What is this chain rule says that? Or how to identify whether the function is in a chain rule or not? It is very easy, student. If any function comes under another function, then that kind of functions are differentiating with the help of chain rule only. See, it is a chain. And we have seen a chain in our bicycle, in our two-wheeler, in different places. We saw the chain, that it is linked to the other things. It is a continuously linked things. That is called as chain rule. So here a function is continuously linked. That is, before the function ends, one more function comes and joins the previous function. That kind of functions we can differentiate with the help of chain rule. And in chain rule, continuously we should differentiate. We will get the answer. For example, if I have a function y is equals to sine of log x. This is, we should differentiate with the help of chain rule only. This we cannot differentiate using product rule. Product rule is possible only if two or more functions are multiplied. Student, here, see, it is not sine x. Of course, it's a trigonometric function, but this trigonometric function has angle as log x. That means this log x comes under the trigonometric function. This log x is not multiplied to sine function. This log x comes under the sine function. Student, if we have like this, sine x into log x. In this case, we can use product rule because two complete functions are multiplied here. Sin x is a complete function and log x is another complete function. So in this case, we can call this is u and this is v. So here we can use product rule. But in this case, it is not like this. It is not like this. It is totally different. In this case, what happened? This log function comes under sine function. So there are totally two functions still. Sine function is the bigger one. Log function is the smaller one. First, we'll differentiate the bigger one. So if at all I want to differentiate this, then I can write dy by dx is equals to first derivative of sine. Its derivative is cos. As I said, derivative also has same angle. This sine has angle log x, so cos will also have angle log x. Then after that, what is the next smaller function? Log x. What is its derivative? 1 by x. Continuously we should differentiate here. No addition, subtraction. So what is the final answer? It is cos of log x divided by x is the final answer. So student, like this we can differentiate a chain rule concept. Chain rule is, if suppose I have a function like this, y is equals to u of x, the x comes under u, then this can be differentiated as dy by dx is equals to dy by du into du by dx. This is the formula of chain rule. But instead of going with this formula, we can directly differentiate it like this, because as many functions are there, that many times we should keep on differentiating. Continuous differentiation without any addition, subtraction. Now students, let us solve some problems based on chain rule now. Problems on chain rule. In first problem, find dy by dx if y is equals to log of sin x. So he has given a function y is equal to log of sin x and is asking us to find its derivative dy by dx. solution. Given y is equals to log of sin x. X is the variable here, that is independent variable, and y is dependent variable. So we should differentiate y with respect to x. Differentiate y with respect to x. As I said in the formula, that is y is equal to u of x. So now I know that there are two functions here. Log function is the bigger one now, and sin x is the smaller. Okay, students, here log function is the bigger one compared to sine, because sine function comes under log function. So first I should differentiate log. So dy by dx is equals to derivative of log is 1 by x. Derivative of log x is 1 by x. So here it is, derivative of log of sin x is 1 by sin x into, that is multiplied. What is the derivative of sine function? Because sin x is a smaller function. This also we should differentiate now. Derivative of sin x is cos x. Now 1 into cos x, it is cos x divided by sin x, and we know what is cos by sine. In first PC trigonometry we studied these things. So our derivative will be, it is cot x, because cos by sine is cot. So the derivative of the given function is cot x. Let us go to the next problem. Find dy by dx if y is equals to e power tan x. Student, here also again there are two functions. First function is an exponential function. Second function is a tan x, trigonometric function. So this function is the smaller compared to exponential. Exponential is the bigger here. Given y is equals to e power tan x. So if we differentiate this y with respect to x, then on this we should write, very important it is, differentiate y with respect to x. So its derivative will be, in the list of formulas that given, derivative of e power x is e power x only. So here it is e power tan x only. After this, derivative of tan x. So far we did exponential derivative. Now derivative of tan x. Derivative of tan x is secant square x. That's it, because it's already multiplied. So student, these are the very important problems for second PC annual examination, because definitely they will ask one question from this topic for 1 marks. Let us go to the next problem. If y is equals to root cos x, find dy divided by dx. This time student, under the root it is cos x. So it means first is the root form, root function, then under this root we have cos x. So given y is equals to root of cos x, so differentiate one with respect to x. So this is dy by dx is equals to first root form. We have seen that derivative of root x is 1 divided by 2 root x. X is cos x into derivative of cos. Under the root there is a cos here. So its derivative is minus sin x. So what is the final answer here? The final answer is minus sin x divided by 2 into root cos x. Next problem. If y is equals to sine of e power 2x, y is equals to sine of e power 2x, find dy by dx. Solution. Given y is equals to sine of e power 2x. This time, student, sine is a bigger function and exponential is a smaller one, and exponential has 2x. It has coefficient of x is 2 this time. So anything which is comes in a multiple in derivative, that multiple or that coefficient we'll write it in. We'll write before the derivative. So here, differentiate y with respect to x. Then this becomes dy by dx is equals to derivative of sine is cos e power 2x as it is. Next, derivative of e power 2x. That is this time as e power ax. As I said, a is any real number. This can be written as 2 into e power 2x. If you want to write this in a proper form, then we can write 2 into e power 2x into cos e power 2x. These are the very basic problems of chain rule. I hope you people understood this. If you have any doubt in this concept, you can put your doubt in comment box. And student, if you are new to our channel, don't forget to subscribe. And to help other students, keep sharing our video.